Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Today we're going to take a look at a neat device called the Takara M200 Booster. Can you guess what this thing does? Well, let's find out together. We'll take a look at the case. I'll open the thing up, we'll take a look inside, see how it's built, and then we'll power it up and see if the thing even works. So let's get started. Let's take a look at the face of the Takara Booster. So in this corner here, we have a voltmeter. And it looks like it goes to 150 volts or so. In the center, there's an indicator bulb of some sort. Usually when you see a coily apparatus inside of a glass bulb like that, it's usually a neon bulb. And on this side here, we have a selector switch. So, yeah, it's a selector switch with notches. So it's not a VR or anything like that. So any guesses as to what this is yet? What I'll do is I'll reposition things here and I'll turn it around and we'll take a look at the backside. On the backside of the booster is an electrical outlet right here, and on this side is a line cord that's incredibly brittle. It's not so brittle that it's going to actually break, but it feels like an incredibly hard plastic material. It'll be interesting when I remove this white tape here to see how incredibly rigid this cord is. It'll probably stay in this position right here. So this kind of gives it away what it does right here. It says Takara Booster Model 200A, and it says input voltage 70 to 110 volts, so that would be AC, and the output voltage is 110 to 120. So it sounds like they have a boost transformer in here. It says maximum output power 200 watts. Transformer inside isn't too incredibly big. So it says right here to be used with radio and television only. So I imagine since Japan has a line voltage of around 100 volts and may experience, dips in that voltage, this is probably to convert an American appliance to something that would be used in Japan. So it would basically step up a 100 volt line to around 120 volts. This is my guess at this point at any rate. It's what it looks like it does. So what I'm going to do now is reposition the camera again, and we'll take the cover off and see what they've put inside. I see a whole bunch of colored wires in here. It actually looks pretty busy inside there. So let's take a look. Getting inside the Takara Booster looks relatively straightforward. I don't think I need to remove any screws on the face or any knobs or anything like that to get inside. It looks like it's just going to be these 4 screws here, these 2 on this side, and these 2 on this side of the case, and I imagine the lid will lift off. If there is any catches or anything like that, I'll show you that as I'm going along here, but it looks like it's going to be relatively easy to get inside. On the bottom of the unit, there is a fuse holder right here that's exposed to everything. It looks like it's supposed to have a cover on top of it. You see, nowadays, if this was a modern device, there would be an alarm and there'd be a switch in here. So if you remove this, it would cut the line cord and it would link to your Bluetooth and tell your entire family, and it would, tweet all your friends and everything when you take the little cover off. Back in these days, everything was incredibly simple. You were just expected to know, okay, I need to unplug the line cord before I go sticking my fingers in here, because these are live connections. That's actually, well, look at how loose that is. Fuse is probably even wrong. So the easy way to fix this is just pinch these together like so and put this back in. Like there, that's nice and tight. Fixed just like that. So there is no cover on this. So if I was to ever put this thing into service or anything like that, I would make a small cover that would protect this so that, you wouldn't accidentally slip your finger in there or something like that. Looks like there's just a bunch of mounting on the bottom here. Looks like some rubber mounts, probably to stop the transformer from buzzing maybe inside or something like that, to keep the case quiet. So we'll discover all this when we get inside it. So what I'll do now is I'll just remove these screws on the top here. They look like they're relatively easy to get out. Yeah, they're just really loose. So I'll get all the screws out of the case and I'll be right back. All the screws are removed from the case, so I will lift the top off. Here we go. You'll notice that when I'm lifting the top off, I'm pulling the sides apart like this so that they don't drag and take any paint off. You'll notice on the bottom here, what they've done is they've put little half slots. And if you just loosen the screw off, you can technically just pull the case up. The problem is usually the case is pretty stuck on the sides here because it's been sitting for so long, right? And when you pull up, it's going to drag the paint off. The paint on this is in really nice condition, so I don't want to really damage that at all, even if I repurpose the case down the road for something else, right? So inside this, it's looking pretty busy. So nice little neon bulb here. Look at how they fastened that in. It's like a little shield here. It's an actual thread-in type bulb, and they've just soldered directly to it. You gotta like the way they used to put things together. Creative, you know. Did a nice job. Nice big transformer here. Not incredibly big, but big enough for the job. Nice rubber-mounted feet to try and keep things quiet. So there's a bunch of components in here. It looks like somebody's been in here and replaced this. That is a modern component with some old lead dress. Interesting. A relay over here. And this is just a coil with a spring type strip on it. So it's got some form of a spring type. It looks like it's made out of copper. Spring type clip. This is an early buzzer. So it has a buzzer inside it. So it does have some form of an indicator for something. Hey, look at that. Nice little aqua green colored rectifier back here. That's an old rectifier. So for changing alternating current to direct current right over here. It looks really clean. Doesn't really look like, you know, a whole lot of tampering has gone on inside here. Resistor on the side, river. Common. You see these in a lot of the earlier, I guess you could call them All-American 5 and AM and FM vacuum tube style radios that came out of Japan. You see a lot of this type of resistor in them. Little contacts down there. Very interesting. Limit set over there. And it looks like there's a limit set on this as well. So the next thing to do is plug this thing in with this incredibly stiff line cord. Wow, I'll move this forward here so you can see the line cord. Look at this. It's like a spring. That plastic is just so incredibly hard. It's not like breaking, kind of like brittle crack off the actual copper wire inside hard, but it's brittle and hard. So it's somewhere between breaking and not. And this line cord, it feels like an extremely hard plastic material. You can actually hear it. How incredibly hard that plastic is. Wow, that's brilliant. You use this thing as a suspension spring in a truck or something. Look at that. Okay, so what I'm going to do is I'm going to get my Variac isolation transformer and current limited supply attached to this thing. So if there is anything wrong inside this, say the transformer has a short in it or something like that, when you see the cover missing to a fuse and you see a fuse rating of, what is this? 3 amps. So it's rated for 200 watts, but there's a 3 amp fuse in there. Right there's a warning sign, so it may have an issue. You know, the reason that the fuse cover is actually missing. So I'll just put this in here. It doesn't matter because it's going to be attached to a current limited supply anyway. So if anything goes wrong, my other supply will take care of things. So that's what I'm going to do. I'll get everything plugged in and hooked up. We'll see what the thing does. I'm looking forward to hearing that buzzer. The Takara Booster is now attached to my isolation transformer and Variac supply. Right now, the line cord on this unit has 100 volts AC present. You might be asking yourself, why is there only 100 volts AC on the line cord when we have 120 volts here in North America? Well, if you recall earlier, the tag says input voltage range is 70 to 110 volts AC. So if I was to put 120 on that, that would exceed that. The standard line voltage in Japan is 100 volts AC, and that's what leads me to believe that this device was created to operate a North American device in Japan. So basically to step the line voltage up so that the North American device would be happy. Transformers can be configured in a buck or a boost configuration. Right now this is configured in a boost configuration, so we can take that voltage and boost it up. Boost that up to 120 and whatever this will allow us to go to. I think it only allows us to go to 120. After 120, it's in the red line there, it seems, so it'll probably allow us to go up to 120. So I'm imagining that these relays and stuff in here are probably protection devices, and it has a buzzer, so it has some form of an alarm. So we'll fool with all that here in just a moment and see exactly how this thing works. Now, this device here has 100 volts AC exposed all over the inside of this thing right now. So if I was to go about poking my hand in here, I would get a nasty shock. Devices way back when were put together like this. Everything was exposed because there was a cover on top of it, and you weren't supposed to go inside unless you knew what was going on. And they were just built like that. They expected the technician or engineer or whoever was working on this thing to know that at the time. Times have changed a lot since this thing was made. Everything has got a 3-wire plug on it. We now have GFI receptacles in our house. You know, you buy a modern device, it has 3 layers of heat shrink tubing on a line that's got 30 volts on it. You know, there's a 911 written in the chassis and a respirator tucked off in the corner and a, you know, Tyvek suit for you to wear and safety goggles and everything. Way back in the day, they didn't do that. They just expected you to know what was going on inside. If you didn't know what was going on inside, you didn't go inside. So if you're following along, you're doing so at your own risk. Just know that this is a dangerous device to work on. Let me do the dangerous stuff. Okay, I'm about to turn this thing on. What do you think is going to happen? So let's take a look. Shield some light on the meter here just in case we get any action on the meter. So here we go. Look at that. Doesn't that look nice? That neon bulb, it looks hot. Now, neon bulbs only get warm to the touch, but it just looks like it would be incredibly hot. Well, that's why. It looks like a stove element. What a neat looking neon bulb. See, stuff like this way back when had character. You don't see stuff like this anymore. So the meter, the needle is pointing right in the middle between 100 and 120, so I imagine that's 110, which tells me that this voltmeter is most likely watching what's at the outlet, because we have 100 volts AC on the line, so that would be over here, unless, of course, the meter is reading wrong. Let's see what happens when we move this switch. I moved up to 120, so this is looking at the output, not the input. Would have been handy to have a switch so that you could look at the line cord and then look at the output at the same time, so input and output, but I guess they figured that maybe it's more important to know what's coming out of this thing than what's going in. So you kind of had a relative idea that it would be at 100 volts or around that, right? So the bulb does get brighter. It doesn't really show that well on camera, but you can see it's a little dimmer in this position, a little bit brighter in that position. So this is most likely on that outlet as well. Let's see what happens when we go to 3. Oh, it shuts off. So this is in the red area and it shut off, but the transformer is still working because I can still feel the buzz in the case here. So the actual transformer itself is vibrating a bit. Let's see what happens when we go. You can actually hear the buzz now. I don't know if you can hear that. So it sounds like that relay is clicking in. Let's see what happens. Oh yeah, you can see the contacts down in there. So that's the protection device so that you don't overload your appliance, which makes me wonder why that buzzer isn't going off. Let's see if the buzzer should be. Yeah, I can feel the coil is energized. And now it's off, now that the bulb is glowing again. So, yeah. So if I touch this here, yeah, you can see. I'm now acting like the buzzer. Which tells me that somebody has probably tightened this thing up so they don't have to listen to it. Let's see what happens. I imagine this is going to sound horrible. Let's find out. Okay, here we go. That wasn't all that tight either. Oh yeah. Yeah, that's horrible. So I imagine, you know, just the fact that you're turning this up too high and the thing's cutting off, and, you know, you've, you know, pretty much reached the point where you might be overloading your appliance. If that's not bad enough, they put something in here that would scare the pants off you when you can tell how loud that is. That's loud on this end. Okay, so that's horrible. It works. I'm going to tighten this thing back up so we don't have to listen to this while we try it out. It wasn't even very tight, so definitely somebody's been in here. Well, we can tell that because that capacitor's been replaced, right? When I'm pointing to this thing, I'm a long ways away from it, so I don't know if you can tell if I move my hand. So it just looks like I'm very close to the exposed stuff in here, but I'm not. I'm you know, quite a bit higher than the unit. I can stand a screwdriver here, but you can't tell the depth, really. So I'm nowhere near poking my hand in this thing. So it looks like it's working. The next thing to do would be to test the output and see if this is accurate to what's on the meter. So I'll get that set up and I'll be right back. I have the voltmeter attached to the outlet here. So let's see what happens when I turn this thing on. So here we go. That's very close. It says, you know, it's pointing right at 110, so 111. Very nice for an analog meter. And that's really close to 120. So we're not looking at that square on, so kind of hard to look at it square on because of the glaring lights and everything. But very, very close. So the meter's working very well. So I can actually move the focus over to this here. See that? So very, very close. 122, and then it just shuts off. So we're down to 11 volts or so. Focus in on that again. So there it is. So it'll allow us to get to 120 volts comfortably, a little over 120. And the accuracy of that meter is to be expected. So everything is working really nice. So what I'll do is I'll get a light bulb and I'll plug a light bulb in and see what happens. I have my load attached to the booster. Let's see what happens when I turn this on. Not bad, that's 110. And that's 120. So nice and bright. And if I go one extra notch, it just shuts it off. So it's working really well. To restore this little device really wouldn't be a whole lot of work. I'd replace the line cord with a polarized line cord. The outlet is polarized, oddly enough, but the line cord isn't. So replace this line cord, replace the grommet, make a cover for that fuse holder in the bottom here. Might put a bit better capacitor in here, change that capacitor out, clean the relay contacts, things like that. And there really isn't a whole lot more to do inside this thing. It works just fine. So it really is a nice looking little case. It would be nice to repurpose and build a project into this, but on the same hand, it's in such good condition, it would be kind of a shame to destroy this thing. It looks so nice, even with this nice little glowing neon bulb in here. Which brings me to the electronic trivia question of the day. Here is your electronic trivia question, and I'll answer this question in the next video. I'll try and include a little bit of trivia for you in the upcoming videos, some strange electronic stuff that isn't normally talked about. And I talked to a lot of engineers that designed stuff with vacuum tubes back in the day, and they can't even get this question right. So here you go. Here's the trick trivia question. This is a regulator tube. This is a 0A3 tube. So sometimes these are used as a reference. So this will control a larger pass element like a 6AS7 or something like that, usually through a smaller tube. So technically this would control a 6AU6 and the 6AU6 would control, say, a 6AS7 or a 6L6 or something like that. But these are sometimes used as references, but most of the time when you find a tube like this on a chassis, it's its own regulator. They're actually just using this as a shunt style regulator itself. They come with all sorts of different numbers, and they have all sorts of different voltages. So this one here is a 0A3. They have 0D3s. They have 0C3s. There's all sorts of different styles of regulators, and they also glow different colors as well. These here are very close to neon bulbs. This is just a standard neon bulb right here, and this is a very special style of neon bulb. It's rated at 82 volts, so this is the equivalent to, say, an 82 volt Zener diode. And this is just a standard neon bulb. Believe it or not, neon bulbs are used as regulators in many pieces of circuitry. So here is the trick question. On the underside of a chassis, sometimes you'll have a little regulator like this, or sometimes even a big regulator like this, mounted below the chassis. Very close to it, you'll have an incandescent bulb like this that's just tied to the filament line. So when you turn on the piece of equipment, you have a filament that's glowing on the underside of a chassis. So there's no jewel lamp, you can't see the bulb, nothing like that. They just have a light bulb on the underside of the chassis, and usually it's close to one of these devices. Why do they have an incandescent bulb close to one of these devices on the underside of a chassis? There is your trivia question. I'll answer that in the next video. Thanks for stopping by the lab today. I hope you've enjoyed this short video on the Takara Booster. If you did enjoy the video, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this in the near future. We'll be taking a look at vacuum tube and solid state devices alike. So there'll be a lot of repairs, troubleshooting procedures, restorations, and even circuitry design on this channel. So if you haven't subscribed, now would be a good time to do that as well. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, and also getting access to some of my personal electronic designs, you're going to want to check out my ongoing electronics course. I'll put the link just below the video description under the Show More tab. So just below this video is a description, and just below that description is a Show More written in capitals. If you click on that, it will expose the link. I may even pin the link at the top of the comments section. So until next time, take care. Bye for now.